Here we have an image of a cell phone charging. And if you're being curious, like I would love for you to be, what would you wonder? Hopefully you would wonder, what time will the cell phone be completely charged? And I've owned a few cell phones that actually just tell me that. When I plug it in, it tells me when it's going to be completely charged. This one doesn't have that feature. So let's see if we can figure out, it doesn't show the 100% charge. Let's see if we can figure out when that would be. Now it seems like this is charging in a pretty constant, consistent manner. So I think that we could think of that as a linear relationship. Maybe we could talk about percent charged per minute or something. So I think to start out, maybe we should find a couple of ordered pairs. Maybe more than a couple. I think I see 6 on our worksheet. So we would need to freeze time right here. Why don't we do a screenshot? 9:42, 51% charged. 9:20, 27% charged. 9:06, 9% charged. 9:23, 30% charged. 9:30, 37% charged. 9:14, 19% charged. Now, you know what? If we're going to put that on a graph, I feel like I shouldn't be plotting times like 9:42, because then what happens after 9:59? It would switch to, that would just be a little confusing. So I think it might be a little more sensical to just say that our x value will equal the number of minutes after 9 o'clock. So 9:42, we'll just call that 42. So when I looked at how I would label the x-axis here, I saw that cut in the graph, but I wanted to go 0, 10, 20, 30, 40, 50, 60, but I guess it makes sense that 0 wouldn't be right on here because that actually stands for 9 o'clock. So maybe the day started at midnight or something. And then level of charge, we should be able to just number those by tens. And let's plot those points. That actually looks really nice and linear. Let's try drawing a line through those. Now in theory, all of those points are exactly on the line because this should be a linear relationship. I guess there could be a little bit of error, but it says to calculate the slope of the line. And so we'd probably just want to pick out 2 points to calculate our slope, I suppose, right? Any preferences here? I'm thinking of just maybe taking these nice round numbers here, the 20 and the 30. So we know that slope is rise over run. And rise is calculated by subtracting the y's. And run is calculated by subtracting the x's. So it looks like my rise, I went from 27 to 37, so my rise was 10%. And my run, It went from 20 minutes to 30 minutes. So that was 10 minutes. So we got ourselves a slope of 1. It says to explain with units what this value represents. I'm going to ask you to do that a lot. And I think the easiest way to do that is go back to the idea of rise over run, y over x. Just look at this graph. What does the y value represent? It represents percent. And what does the run represent? The time, and I guess we wound up labeling that in minutes, minutes after 9 o'clock. So that actually gives you your label, percent per minute. So explain with units what this value represents. I would want you to explain that that 1 represents percent per minute. I also want to make sure that you talk about positive and negative. So since that was a positive 1, what does that imply? That it's an increase. It's not that our phone is going down 1% per minute, but we would actually say that we've got an increase of 1% per minute. We're now being asked to find the y-intercept. And I guess since we did label it as 0 right here, we would be looking for that number right there, where our line crosses where x equals 0. That's a good point. Whenever you're looking for a y-intercept, you would be talking about where x is equal to 0. Because don't all points on the y-axis have a value like 0.2 or 0.5 or 0.7? And so whenever it says to find the y-intercept, you should think, oh, that means x equals 0. Now how are we going to find that y-intercept? I guess I'm sort of drawn to the y equals mx plus b. What do you think? Because they are asking me to find the y-intercept. So the only thing I know so far is that I'm using a slope of 1% per minute. But we really haven't figured out b. That's the goal here. So what can we do? Well, in theory, any point on this line, if you plug in its x and its y value, it should make this equation true. So if I take any point on that line and plug in the x and the y value, that should help me figure out what b is. Now this is a real world thing, so there might be a little bit of error, so it will make a difference which point we choose, but they should all be pretty close. Let's go with that 20, 27. So if I put the 27 in for y and the 20 in for x, just temporarily, I get that b equals 7. So we found the y-intercept. It is actually 0, 7. It's important to me that you can tell me what does that represent. And if you need to go back to what does x and what does y represent, when the time is 0, but remember, what does 0 mean? 42 meant 9:42, so 0 must mean 9 o'clock. And the 7 represents our y value, our level of charge. The phone was charged to 7%. So make sure you use those clues from the graph. Always pay attention to what the labels are on those axes and you should be good. And we are so far ahead of the game, we already wrote our equation for the line. Y equals 1x, and now we just have to fill in that y-intercept we just figured out. Y equals 1x plus 7, or since you don't really need to write the 1x, y equals x plus 7. When we go back to our table, for sure these 2 points will be a perfect representation of the y value equaling the x plus 7, y equals x plus 7. Here's another one, the y value equals x plus 7. These other ones might be a little bit off, right? Or quite a bit off. If we wanted to do a better job, we probably would have taken more sample values and maybe calculated a few different slopes and averaged them or something, but well, I'm just trying to keep it simple here. So if we're going with that equation is our equation for the line representing how fast our phone charges, at what time will the phone be fully charged? When I ask you questions like this, it helps to figure out when it says at what time. Our answer is going to be a time. Our answer is going to be, is that an x or a y value? A time is an x value. So we're going to be figuring out what x equals. And when the phone is fully charged, that should give me a clue about my y value, right? Y is the level of charged. What does it mean to be fully charged? It means 100%. So they're actually giving me a y value and just asking me to find the x value. No problem. So I'm going to take that equation, I'll plug in 100 for the charge. We're going to solve for x. And remember that x equals 42 means 942, so x equals 93 means 993. That's a little messed up. Can you tell me what time that actually is? 9:60 is 10 o'clock. So are we talking in 10:33 here? So we can say that our phone should be fully charged by 10:33. Let's talk a little bit about domain and range. Remember that domain is just talking about all possibilities for x, and range is talking about all possibilities for y. X values standing for minutes or time here. Y values standing for percent charge. So definitely percent charge would only go from 0 to 100, and the domain, I suppose, would be the times that the phone is plugged in. The earliest time I saw on the phone was 9:02. So I'm going to say that we probably shouldn't assume that the phone was plugged in before that. So I'm going to say that the domain starts at 2. And how long was it plugged in? Well, we should be able to say that this model will hold until it gets fully charged. So we figured out that once we get to 93 minutes, our phone should be fully charged. And what was my percent at 9:02, at minute 2? Where if we're following this model, it would be 2 plus 7. So the phone would have started being at 9%. And then we left it plugged in for 93 minutes until it got up to 100%. So if we were talking about the domain, we would say the phone was definitely plugged in at 2. And that model would stop being effective once the phone was charged. We're not going to get over 100%. And the range, since it would have started at 9% when it was plugged in at 9:02, theoretically. And our range would not go anywhere past 100 because we're not going to get more than a 100% charge. So that's the idea of domain and range.